Welcome to Homework Lib.
Hello students, in this question two balls of masses m1 and m2 are moving along the same straight line, striking one another on head-to-head collision, and this collision is an elastic collision. So we have to show that the magnitude of the relative velocity before collision is equal to the velocity after collision. So the initial velocity of ball 1 is u1 and the ball 2 is u2, and the final velocity after collision is v1 and v2 respectively. So u1 u2 is initial velocity and v1 v2 is final velocity. So in this question we are going to use the conservation of momentum and the concept of relativity. So the relative velocity before collision is equal to relative velocity before collision. So that will be V relative is equal to u2 minus u1. That is initial velocity of ball u2 minus the initial velocity of ball u1. And the relative velocity of the balls after collision. So that will be equal to V prime relative is equal to v2 minus v1. So we have to show that the magnitude of relative velocity before collision is equal to the magnitude of relative velocity after collision. So for proving this, we use the conservation of momentum in an elastic collision. That is initial momentum before collision m1 u1 plus m2 u2 is equal to the final momentum after collision m2 v2. Let it be equation 1 and this be equation 2 and this be equation 3. So from equation 1 we can rewrite it as m1 u1 minus m1 v1 is equal to m2 u2 m2 v2 minus m2 u2. So rearranging this and taking the masses commonly outside, we get m1 equal to u1 minus v1 equal to m2 into v2 minus u2. Now dividing both sides by m1 into m2. So dividing by m1 m2, we get u1 minus v1 by m2 is equal to v2 minus u2 by m1. So using this equation 2 and 3, we can write that V relative, so modulus of V relative by m2 is equal to modulus of V prime relative by m1. Since the masses are positive quantities, we can multiply both sides by m1 m2, and simplifying this we get the modulus of relative velocity before collision is equal to modulus of relative velocity after collision. So from this we can show that the relative velocity before collision is equal to relative velocity after collision. And for question number 2, if the video of such collision is made and shown to the audience, they could not determine whether the video was being run forward or backward. So this is because the motion of balls in an elastic environment is time reversal invariant. So when the video is played backward, when video is played backward, the ball's motion would appear the same as in the forward case. For the third part of the question, if the collision were inelastic, then time reversal invariance should not hold true. Since in inelastic collision, kinetic energy is not conserved. So if it is not conserved means then the relative velocities before collision is not equal to the relative velocity after collision. So in this case the time reversal invariance should not hold true. So for example, in completely inelastic collision where the balls stick together, the relative velocity after collision is equal to 0, but the relative velocity before collision is not equal to 0. So in this case, the time reversal invariance should not hold true. So here, time reversal invariance does not hold. Hope you find this video is useful. Thank you.